All right, good afternoon, good morning, and good evening, depending on where you are watching us from. So in this presentation, we want to look at one, the definition of rational and irrational numbers. Two, how to express decimal numbers as rational numbers or as fractions. All right, how to convert the recurring, all right, the recurring decimals as rationals or as fractions. Now, by definition, a rational number, a rational number, a rational number is a number that can be expressed as a fraction, That is in the form A divided by B for A and actually maybe we say for every A and B is an integer, and that B must never be equal to 0. So if the numbers can be expressed in this form, if a number can be expressed in that form, then that number is a rational number. All right, note we note that it is a rational number denoted by this symbol, right? So we are saying we need to express it in this manner. So that symbol is a symbol for rational number, that is A, for every A, B belong to set of integers, and that B is never equal to 0 as a matter of emphasis. So as long as you're able to do that, then that is a rational number. Now, you need to take note of these points. Number one, all terminating and recurring or repeating decimals are rational numbers. Why? Because they can be expressed as fractions if they are lowest term. Right? You must be able to express the fractions in their simplest terms. All right? So, all the square roots of perfect squares are rational numbers. Okay. This also takes us to this point. All digits e.g. 0, 1, 2, so on, are rational numbers because we can express such as a fraction. All right. Now, if you talk about irrational numbers, we are saying these are numbers which are not rational. Are not rational. All right, implying that all non-terminating and non-repeating or recurring decimals are irrational numbers. Okay, are irrational numbers. Also, as a matter of emphasis, all the square roots of non-perfect squares are irrational numbers. Are irrational numbers. Right? E.g., for example, square root of 2, square root of 3, square root of 5, square root of 6, square root of 7, square root of 8, etc. These are irrational numbers. Okay, so we know what rational numbers are. We are saying, are we able to express these numbers as fractions? If we are able to do that, then we'll say, all right, we have rational numbers. Is that okay? Okay, we have rational numbers. I hope that is fine. Okay, let's see if we can get some questions. I can get some questions. Do you have any? Do you have any? Yes, have. Should have. Yes, I wrote. The question is, okay, maybe we can say some examples. Express the following in the form A divided by B, for B is never equal to 0. The first one is 0.3 with a bar. Second one is 0.24 with a bar. And the third one is 0.785, the bar starting from A. Okay. So let's look at our solutions. So we know, all right, all of us know that 0.3 with a bar is the same as 0.3333 up so on and so forth. It is repeating. Then we can let x be equal to 0.3333 up so on and so forth. And we call this equation 1. Now, what is it that we need to do here? We need to produce two equations, all right? Two equations with a decimal point. But we must ensure that after the decimal point, as you go to the right-hand side, whatever numbers are there are repeating, are recurring. So if there's anything that is not recurring, then you can put it the other way around. Now, if you check here, we are saying the rule is to take at least one, all right, to the other side and ensure that whatever will remain is recurring. If I took this 3, the other side, I'll remain with 333, which will be recurring. Then it's fine, I can just take the 3. All right? But if maybe this was 4, then 333. So it would be better for you to take everything, the 4, 3, so that whatever remains there is the one that is the recurring. All right? So you get this plus what is recurring, you take it to the left-hand side. Okay. So now, but in this case, even if we took just one, this one is recurring, all right? So we can take it to the other side, it's fine. And now we can do that by multiplying by 10. In other words, this decimal point will move one step to the right. Okay. So what does it mean? Okay. We need to multiply equation 1 by 10. What does this imply? We have 10 open bracket x is equal to 0.3333 with these dots up to infinity, all right, or infinite. Okay, so upon distributing the 10, we have 10x is equal to 3.333. And we call this now equation 2. We call that as the equation 2. All right. So now, we subtract equation 1 from equation 2. Okay, that is, we have 10x, this 10x minus this x. This will be equal to this 3.333 minus this one now. So we have 0.3333, so on and so forth. Now, what does this imply? This implies that when you subtract here, you get 9a. This will be equal to, now, because these are the same and they are repeating, it It means when you subtract, that will be 0. Therefore, just subtract these 3 and 0. So it will be 3 minus 0 there. Okay. If you want, you can say point what 0 because there will be a 0 there, which is the same as 0. So this implies that we'll have 9x being equal to 3 divided by 9 divided by 9. This implies that x is equal to 3 over 9. But now, for us to express that such decimals as fractions or as rationals, must express them in their simplest form, right? Meaning that you cannot divide any further. So this implies that x is equal to 1 over 3 when we divide throughout by 3. Therefore, the required form or fraction is 1 divided by 3. Basically, you are done. So what is happening? We are creating two equations, then subtract. All right, let's look at the next one. Okay, the second one is B. B, we have got 0.24. Everything is decaying, right? Everything is decaying. So this implies that this is 0. Please, this is not an arrow, just a bar there. This 2.4.24 is the same as 0.24, 24, 24, so on and so forth. All right. Now we can say, all right, let x be equal to 0.24424 up to positive infinite. And we take this as 1, the first equation. Now, you observe one thing here. It's 2 digits that are repeating, that are recurring. So it's better you take away the digits that are recurring the other side, not cut off. Right? It's 2 digits that are recurring. So now, in other words, we must take this point to the right-hand side. So we need to move by 2 steps, implying that that can only happen if we multiply by 100. Okay? And we multiply this equation by 100. Okay, that is 100 open bracket x is equal to 0.242424 up to positive infinite. What does this imply? We have 100 dx is equal to 24.2424 up to positive infinite. And we take this as our equation 2. Right. Now, we are going to subtract these two equations, right? We subtract equation 2. We subtract equations 2 and 1. All right, implying therefore that we'll have 100x minus x. The 100x we are talking about is this minus this x. Hope that is okay. This is equal to, we subtract now this minus this, right? Okay, great. So 24.2424 point dot dot up to infinity minus 0.242424 point dot dot up to positive infinite. Now, like we said, because after the points these are exactly the same, once you subtract them, they'll give you 0. Therefore means that you subtract 24 and 0. This will give us what? 99x is equal to 24. We divide throughout by 99. X becomes 24 divided by 99. But now we must give a simplified fraction. So we can use 3. 3 into 24 is 8. That is 33. So therefore, the required form or fraction is 8 divided by 33. All right, this is what we have done so far. So follow the skill that we are applying here. Please, in case you want lessons for university mathematics, first year mathematics, please don't hesitate. Contact us on the following. We conduct live lessons, online lessons, that is. Live will be able to teach you direct. All right, this is for Mr. Piri, who is myself. Then 0979 3738 09, Mr. Mbondo. All right, any of these, any of us in short, all right, and don't forget to subscribe to our new channel, which is Piri Kamban, right? JM. You'll be finding, you'll find a lot of videos which we are trying to promote, right? And we are yet to upload a lot of videos. Let's proceed. Let's look at C. We have got 0.785 like that. So like what we've been saying, it is clear that 0.785 is the same as 0.78585 and 85, so on and so forth. Therefore, let x be equal to 0.78585 because it is only 85 that is repeating, and we shall call this our equation 1. Now, this is how somehow different from the first two. We realize that there is a number there's a number here which is not repeating before these numbers repeat, right? So first, let's come up with an equation which will only have repeating numbers after a point. So we must take the 7 the other side, right? So and we can say multiply this equation by 10. All right, that is 10 open bracket x is equal to 0.785585 up to positive infinity. Upon simplifying, 10x is equal to 7.85 85, and we call this the equation 2. All right, that's a starting point. Then now we can come up with another equation which now would take everything, this up to where we are repeating. All right, so we take it the other side as well. Okay. Okay. Next, we multiply equation 1 by, that is 1,000. All right, that is 1,000 x 0.785 up to positive infinity. So upon simplification, we have got 1,000x is equal to 785.85 up to positive infinity, and we call this equation 3. So now we are going to subtract equation 2 from equation 3. Now we subtract equation 2 from equation 3. All right, that is 1,000 x minus 10x is equal to 785.85 minus this is 7.8585. So you can see that our aim is to try and get these that should be the same. If we do not remove that, we do not remove 7, we're going to have 7, then we're not going to get a 0, right? So now this will give us 990x to be equal to you subtract 785 minus 7 to be 778. All right, 778. Okay, please verify that. Okay, so you subtract. In case it's not clear what I've done, let me say 785 minus 7. Okay. So we are saying this is 990x is equal to 778. Hey. But so we divide by 990 by 990. X will be equal to, so when you reduce this, you have 389 divided by 495. This is the required fraction. You can say, therefore, the required fraction is 389 divided by 495. And that's it. That is how we express these as fractions, right? For terminating decimals, I think these are straightforward. For example, 0.5, one we express it as a fraction, we say over 1 times 10, 10, 5 over 10. This is 1 over 2. These are straightforward, all right? Okay. This is where we end for this presentation. If you enjoyed it, please subscribe, give us a comment, get in touch with us. We should be able to help you. If you're dealing with investment mathematics first years, we are here to help you. Contact us. We should be able to help you, all right? We should be able to help you. Okay. And also subscribe this channel, like we are saying, JM. Okay. Like I was saying, it has been Philip Kamban. Till next time. Bye-bye.